Okay, so in this video, we want to review two basic properties of exponents, and that is how exponents behave over a product and a quotient. So, in general, if you take xy to the nth power, this is the same as x to the n times y to the n. So you can distribute a power over a product of any two terms, and the result is also true if there were 3 terms here, 4 terms, and so on. And the same property holds for a quotient. So, if you have a quotient, x over y, and you take its nth power, the power can also be distributed on the numerator and denominator, so this is the same as x to the n over y to the n. And this goes for any choice of real number n. And let's quickly verify why both properties should be very intuitive. If you look here, thinking of n as a positive integer, this is if we expand it x times y multiplied n times. So there will be n x's. If we regroup them together, we get x to the n. And there will be n y's. So regrouping them together gives us y to the n. And we can do so because multiplication of real numbers is commutative. And the same here goes, except it's even simpler. If you expand this, again thinking of n as a positive integer, this is x over y times itself, n times, so there will be on the numerator n x's, giving x to the n, and the denominator n y's giving y to the n. Let's look at two very simple examples where we simplify the property. So what if n was simply here 3? Then we would have xy cubed. By definition, if you cube something, whatever it is, you must multiply with itself 3 times. This is therefore xy times xy times xy. And now if we simply regroup the x's, first we get x, x, x. There are clearly 3 of them. And then the y's, there are also 3 of them. And then of course, x times itself 3 times is x cubed. And y times itself 3 times is y cubed. So indeed we can distribute an exponent onto a product of terms by distributing onto each individual term. Let's play the same game now with the quotient. So what if we had x over y cubed? And as we've said before, this is even simpler. This is x over y times x over y times x over y. So if we regroup on the numerator, we have x times itself 3 times. This is of course x cubed over y times itself 3 times y cubed. And as I've said before, this also works for a product of 3, 4, and so on, as many terms as you want. So if you had, say, xyz to the n, the same argument applies. This will be x to the n, y to the n, z to the n. So quite simply, whenever you have an exponent applied to a product of terms or a quotient of terms, you can always distribute the exponent onto each individual term. And that's it.